Today, AI's intelligence has seemingly surpassed that of human beings. Elon Musk's SpaceX will likely soon be capable of taking us to Mars. The world is indulging in celebrating the revelry of technological inventions. Has anyone questioned AI about what substantial improvement the material world has achieved since humanity entered the information era half a century ago? The harshest reality is that the energy efficiency of the industrial, transportation, and building sectors is not significantly different from that of the pre-information age. Global carbon emissions haven't decreased yearly as stipulated in the Kyoto Protocol. Instead, they have increased by 4 times. People still use concrete, as fragile as glass, to make buildings. This is a disgrace to the information age. The good news is, Broad R&D team has successfully invented an ultra-strong and ultralight sandwich structure, core slab. Slim stainless steel core tubes and copper foils are sandwiched between 2 plates, which are fastened by 1100 Celsius degree oxygen-free high-temperature brazing. The core slab is 10 times stronger in stiffness and strength than ordinary metal sheets and can be manufactured on large scale and at a lower cost, offering a fundamental solution to the century-old challenge of lightweight materials. It can reshape the construction, transportation, and energy industries. Since 2009, the Broad Group has invested over $1.1 billion into high-tech home, known as Holland Building. All the components are 100% factory-made, enabling a 100-floor high-rise to be built on-site within 1 month, reduces energy use by 90%, and delivers indoor air 100 times cleaner than outdoor. Due to the use of core slab in Holland Building, the steel consumption is low. This makes it possible for buildings that are made from carbon steel that is too expensive to now afford a stainless steel building. Without using any concrete, the material can last 1,000 years, significantly extending the boundary of human fortune. Since 2017, we have been applying the core slab into the road panel and beam development of high-tech elevated highway, capable of supporting vehicles more than twice the weight of the industry standard. The prefab modules are transported in container-sized units and installed on-site using only bolts, so it is possible to install 10 kilometers of highway within only 1 month. The cost is reduced by half, provides great potential for elevated highway to fully replace ground-level roads, and significantly expands the ecological boundary of the land. Meanwhile, the Broad Group is developing offshore wind turbine using truss-style double-layer wind blades and core slab floating structures to create an ultra-high-strength, super-long span integrated system that can withstand a once-in-a-century hurricane without damage. More importantly, the aluminum alloy blades can solve the environmental pollution problem caused by the disposal of traditional fiberglass wind blades. This largely extends the lifespan of wind blades by 3 times, redefining the cost boundaries of renewable energy. The Broad Group is currently implementing the world's largest 30 megawatts wind power project. With an innovative self-climbing crane, the tower can be constructed up to 300 meters to harness more wind energy in plains and hills than on mountains. For every additional 100 meters in tower height, wind power doubles. This conclusion is drawn from years of monitoring and comparison between 330 meters towers and 600 meters mountains, which will break the boundary of the global application of renewable energy. The Broad Group is developing the world's largest 500,000-ton cargo ship, structured by a core slab floating system, contributing a draft depth 1/3 that of a traditional cargo ship. This design allows it to navigate in rivers and directly reach the source of goods. The ship carrying a 40-megawatt wind power generator enables fuel-free, pollution-free sailing, cutting shipping costs tenfold and greatly expanding the boundary of global logistics. Since 2018, Broad Group has collaborated with the world's leading maglev lab team on vacuum train development. Leveraging our 30-year service experience and global applications of vacuum technology in over 80 countries, the speed of zero-resistant maglev train and core slab vacuum tunnel can astonishingly reach 7,000 kilometers per hour, 20 times faster than a high-speed train while consuming 50 times less electricity. Even if it is enormously costly and highly controversial, the conclusion is clear. Since vacuum is the boundary of air resistance and maglev is the boundary of friction resistance, vacuum trains are certainly the ultimate boundary of transportation technology. In 2018, the group has also started developing the Air City, an enormous aircraft featuring 3 layers of wings, the 4 decks of cabins, and over 3,000 seats. Featuring ultra-strong, lightweight aluminum alloy core panels for the fuselage, wings, and floors, combined with a robust, vintage-inspired 3-layer wing design, the aircraft weight is reduced drastically. Its wing area is 4 times and cabin area 5 times larger than the A380, the world's largest airplane, with only a 30% increase in the overall weight. The fuel consumption per passenger is merely 0.7 liters per 100 kilometer, a reduction of over 70%. Although electric power is not applicable due to its limited range, the Air City approaches the ultimate boundaries of carbon reduction, safety, and comfort in global aviation. We have also successfully developed and passed the wind tunnel test for the Sky City, a residential tower that can reach up to 1,100 meters. Consisting of over 20 open platforms, the Sky City can support more than 80 12-story Holon buildings, over 100,000 square meters of green spaces, and 20 swimming pools, which can accommodate over 30,000 residents to live and work together. With 100% prefabricated Holon buildings and on-site installation by self-climbing cranes, the project can be completed within a year. The construction costs will be similar to that of a conventional building, but living expense will be lower based on near-zero energy consumption technology. More importantly, Sky City can save urban space by 10 times, greatly relieving transportation stress and pushing the boundaries to a higher standard of urban living and economic development. Since the outbreak of COVID-19 in 2020, Broad has started mapping out an ocean city. It consists of a large vessel loaded with over 70 30-story Holon buildings, a 1 million square meter factory, and 500,000 square meters of green spaces. It can accommodate over 50,000 people to live and work together. Its rooftop will feature a 3,200 meter long and 72 meter wide airplane runway, capable of handling the world's largest aircraft's takeoff and landing. The ship's hull, constructed from core slabs, features over 3,000 prefabricated modules that can be assembled and bolted on water, enabling the construction to finish in 2 years. Essentially, each module is an enclosed, floatable unit, ensuring the vessel remains unsinkable even in the event of iceberg collisions or in wartime. The ship is equipped with 128 megawatt of wind power, fully supplying energy for onboard fishing and agricultural demands, as well as for living and navigation purposes. With the hull and structures entirely produced in factory assembly lines, the total budget of the massive project will surprisingly be less than $5.5 billion, which is around $110,000 per resident, making large-scale migration entirely possible to the ocean sphere, 3/4 of the Earth. This significantly expands the boundaries of human habitation. Among all the 9 concepts mentioned before, only Holon building, elevated highway, and wind power have been successfully developed. The remaining concepts haven't been achieved due to the excessive initial financial outlay that is needed. Even successful products face significant resistance when entering the market. Pessimistically, it might take us more than a generation to achieve the widespread adoption of all these concepts. We might helplessly watch the meltdown of the global climate. Coincidentally, we are a company that stays resilient and uses strategy of do more with less money to protect climate. The group invented energy-saving central air conditioning chiller in 1992. With over 30 years of continuous innovation and application in more than 80 countries, its efficiency and lifespan are approaching the boundary of technological advancement. In 2008, when we first realized that improving building insulation has a higher thermal performance and less carbon emission than that of air conditioning, we immediately started to add insulation in more than 20 buildings at Broadtown, saving 80% of air conditioning energy. In recent years, we noticed how the large-scale application of wind and solar energy can be detrimental to the power grid stability. Broad Group has discovered another groundbreaking energy-saving solution called water-based thermal energy storage. This solution requires only a thermal insulated water tank and an intelligent control system. The water tank can be roughly as small as 0.5% of a building's volume year. Just using the fire water tank is enough. The off-peak energy storage not only avoids curtailment of wind and solar energy, but also reduces 60 to 90% of air conditioning costs. These two simple technical solutions reveal another boundary of technological innovation. When humanity pursues complex and mysterious innovations, sometimes the solution lies in returning to simplicity.